All right, now we're going to look at systems of inequalities where we have more than one inequality that we're solving at the same time. All right, so what I want to do here is color coordinate a few things. Otherwise, it's going to get a little bit messy. So I'm going to take this first equation, I'm going to do everything in red. And in the second equation, I'll do everything in green. So you should be able to tell these apart. All right, so the first equation, I want to graph these. Okay, and again, we're just going to take the actual equation as the boundary. So as I go through 2x minus y equals 4, that's the first equation. I want to find the x-intercept and the y-intercept so that I could plot this. The x-intercept is going to be when y is 0. Okay, that gives me 2x equals 4. When I solve that, divide out the 2, you get 2. So that's 2 comma 0. The y-intercept is when the x value is 4, you get negative y equals 4, or y equals negative 4. So 0 comma negative 4 is on that graph. When we work with the bottom inequality, again, we're going to change it to an equation in order to get our boundary. The x-intercept occurs when the y is 0. This term disappears. 3x equals negative 6. Divide by 3, and x is negative 2, so that's negative 2 comma 0 on the graph. And then for the y-intercept, that's when x is 0, so this first term disappears. We get 2y equals negative 6. Divide both sides by 2, get negative 3. So 0 comma negative 3 is on the graph. All right, that gives me good information. Now I want to plot this thing. So let's sketch this out. I'll use black marker for the axes. I don't know, I might be going more than I need to here, but that's okay. I'd rather have it too big than not big enough. Okay. Now, for the red graph, I need 2 comma 0 in the x, for the x, and 0, negative 4 for the y. 1, 2, 3, 4. Again, we talked about this before, that the equal signs in the original inequalities mean that we can keep both of these lines solid, which is nice. Okay, so I'm just going to fill in a few points here using kind of the slope idea and keeping these solid. Okay, it's a decent graph. And then let's do the green graph, that one. Let's see, negative 2 in the x direction and negative 3 in the y. And then we've got to plot that over 2, down 3, over 2, down 3, over 2, up 3, over 2, up 3. Okay, so that should give me a pretty good few points here to graph. Okay, missed a couple, but that's pretty close. A little bit wavy. Alright, not too bad. Now, with the red graph, let's just take that one for instance. I want to do a test point, right? I want to check. The test point is going to be 0, 0, because neither graph goes through 0, 0, so we're okay there. So if I plug in a 0, that's 2 times 0 minus 0. Well, obviously that's just 0. And 0 is indeed less than or equal to 4, looking at the original inequality. Okay, so that's true. So that means 0, 0 works. So I want to shade. If you just look at the red graph, I want to shade the side that includes 0, 0, which would really be all of this on the top left region. Okay, so that's what we want to shade in, this whole area here. I'm going to do this kind of slowly. Okay. Then, with the green graph, I want to do a test point there as well. My test point, I can do 0, 0 again. When I plug those in, I get 3 times 0 plus 2 times 0. Obviously that's 0 plus 0, which is 0, and 0 is not... Oh, wait a minute. No, it is. I was looking at that as a positive. 0 is greater than or equal to 6. Negative 6, sorry. Negative 6. So 0, 0 is part of the solution for the green graph, so I have to shade that on the same side. Okay, and so now the solution to the system, and I'll do this in blue, that corresponds to the original system. The solution to the system is the overlap. It's all points that solve both inequalities together, and that would be this triangular region. It's kind of infinitely triangular, it goes up indefinitely. Okay, and so this whole region here is going to actually be the solution. It's the overlap of the other two. Okay, so that region in blue is our solution.